Hello dear students, so myself Manjunatha PC, working as Senior Assistant Professor in the Department of Computer Science and Engineering, Reva Institute of Technology and Management, Yelahanka, Bangalore. I would like to take a session on the concept of functions, arrays and strings. So before we proceed, so let us see what we have discussed in the previous session. In the last session we have seen that what exactly the functions are. We have seen the introduction to functions, and then we have seen the advantages of functions, why we supposed to use in the programming, and then we have seen how exactly the C language supports the concept of functions in programming, and in that we have seen the function prototype, the syntax of function prototype, and even the syntax of function definition, and the syntax of even the function calls. And later we have seen the categories of the function that we can have based on the return type of a function and even and the parameters that a function is taking for its successful execution of the statements. And also we have seen some of the simple programs on functions. So in this today's sessions we will be learning the lab program exercise 10.a, which is to perform the right rotation of a number bitwise, and then we will see a lab program 10b, which is to list the prime numbers within a given range, and then we will see the storage classes. Under that we see automatic variables, register variables, static variables, and the global variables. When we are using the functions, we must know the concept of storage classes there. So we will see that what exactly storage classes and how exactly we can have the 4 different types of storage classes in C programming language. Now, so if you look at the program 10a, so the problem here is to design and develop a C function right shift x comma n that takes two integers x and n as input and returns the value of the integer x rotated to the right by n positions. So here, so the function name should be right shift, but what exactly the operation need to be performed is the value x has to be right rotated by n positions. So n is the number of bits that the user will enter there. Then assume the integers are unsigned. So here we are treating the numbers as a unsigned number. So there is a difference between a signed number and unsigned number. Unsigned number is always positive, whereas signed number is, it can be positive as well as a negative. So write a C program that invokes this function with the different values of x and n and tabulate the results with the suitable headings. So here, before we program it, we should know what exactly right shift and the right rotate is. Now, and also we should see here what exactly the concept of signed number and an unsigned number. Now, so look at this particular sequence of bits. So assume that, so here I am assuming a 4-bit. Normally the integers are stored with a 16-bit positions. So 2 bytes is the size of an integer. So but here I am assuming that if I am having only 4 bits for storing the integer, how exactly it is stored. Now with respect to 4 bits, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are the possible 16 values what I can have. So this is, so the value 0, this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. These are the possible 16 values what I can have with respect to the 4-bit machine. So that is, so the range what we can have here is 0 to 2 raised to 4 is 16. So I can write 2 raised to 4 minus 1. This is the range what I can have in case of 16-bit machines. Fine. If I am using 4-bit, then the sequence is from 0 to 2 raised to 4 minus 1. 2 raised to 4 is 16, 16 minus 1 is 15. So 0 to 15 we can have a different positive values. Now if I am using a 16-bit machine, then the size of the integer will be of 2 bytes. 2 bytes means 16 bits. In that case, the range of the integer values will be like 0 to 2 power 16 minus 1. 0 to 2 power 16 minus 1. This is the in case of unsigned numbers. All are here the positive numbers. Unsigned numbers. But what exactly the signed numbers are? So here basically when you are using a signed numbers, when you are using a positive value and as well as the negative value. Fine. So in that particular case, how exactly the system manipulate the data here is like the last bit, which I am calling it as a most significant bit, it will be used as a sign bit. This will indicate whether a number is a positive value or a negative value. So if the MSB bit is 0, it indicates it is a positive value, and in case if it is 1, it indicates it is a negative value. So that is, so here 0 represent most significant bit, 0 represent the number is a positive, whereas most significant bit, if it is 1, it represent a negative value. Now we will see how exactly it is getting So done with respect to this. Now if I have a 4-bit machine, again here this is reserved for the sign bit. I cannot gather any value associated with that. It will just say that whether the number is a positive value or a number is a negative value, right? So now among the 3 bits, what are the possible values I can have? So this is corresponding to 0, this corresponds to 1, this corresponds to 2, this corresponds to 3, this corresponds to 4, this is 5, this is 6, and this is 7. What about this particular value? Again I am getting here as a 0, but note that in all these particular cases the MSB value will be 0. MSB value will be 0 in all these particular case. So I say that the number is a positive value. In all these particular cases the MSB bit value will be 1. So here in all these particular cases I say that the number is a negative value. Right. So when this is a negative value, what this particular value signifies? Is it like minus 0? In reality we have only one 0. This is not we cannot say that it's a plus 0 and a minus 0. So beyond 0 we say that negative numbers, and after 0 we say that the numbers are positive. Then how to treat this particular the value 1000 in this particular case? What exactly happens in programming is when the number higher bit, the MSB bit is 1 here, we take the 2's complement of that particular value. What exactly the 2's complement of 100, 1000 here? So the 2's complement of this is 0, 111. So this is 1's complement, and for this I should supposed to add 1 to get the 2's complement. So here I get the same value here. This is the 2's complement, and this is correspond to the value 8, and for this 8 I should append the negative sign. So this value correspond to minus 8. It is not so minus 0, rather it is a minus 8, and the next corresponding value should be like minus 7. So minus 6, minus 5. So this is minus 4, this is minus 3, and this is minus 2, and this is minus 1. So this is the way how exactly the numbers are so used for assigned values as well as unsigned values. Now, so minus 8, after that how is that we get minus 7 here? So what is the sequence here? 1001. So if you take the 2's complement of 1001, what exactly we get is 1001 is the sequence. When I take the 1's complement of this, we get 0110. So this is 1's complement, and for this if I add 1, I will be getting the 2's complement of that. What is the 2's complement of this? So here when I add this 1 here, I get the value as the 7. So this 7 means that append the sign, negative sign, because I am taking the 2's complement, assign the negative sign there. So what is the value I get? Minus 7. Similarly I get minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. So now this is the positive range and the negative range. Now I can have a positive value also, negative value also. Now with respect to this, now if I consider the range of the positive values, what is the range of the positive the range of the numbers what I can have, including the signed numbers? What I can have here is the highest value what I can have here is 7, and the lowest value what I can have here is minus 8, right? So the range is here like minus 8 to plus 7. Minus 8 means here I am using 4 bits. So the range what I can consider is minus 2 power 4 minus 1 to plus 2 power 4 minus 1 minus 1. 2 raised to 4 minus 1 is 2 raised to 3. Minus 8 is the value, the least value what I can have, and the highest value what I can have is here is 7 value, that is nothing but 2 raised to 4 minus 1, that is 2 raised to 3 minus 1. 2 raised to 3 is 8, 8 minus 1 is 7. So minus 80 to plus 7 is the range with respect to the 4 bits. When I go for the 16 bits, so what will be the range of the signed numbers? This particular range what I can give here is the least value is minus 2 raised to 4 minus 1. So when it is 16 bit, minus 2 raised to 16 minus 1, so that is minus 2 raised to 15. 2, and the maximum value is 2 raised to 4 minus 1 for the 4 bits. For the 16 bits, 2 raised to 16 minus 1 is 2 raised to 15. So that is plus 2 raised to 15 minus 1. So this is the range for the negative value. So this is for signed numbers, including positive as well as negative values, right? Here it is only for the unsigned numbers, this is only for the assigned numbers, right? This is the ranges. In general what we can write is, so 0 to 2 power n minus 1 is the range of the positive values, that is unsigned numbers. In case of in general what I can write, this is for unsigned situation, for the unsigned numbers. Similarly, for the signed numbers, the range what I can write here is minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. This is the range for signed numbers. So why is that we should consider even the signed numbers and unsigned numbers in this program? Because we are performing the bit manipulations here. Now, if we consider the right rotation operation, if I consider the 16-bit machine, this is the sequence for the value 22 here. 2 raised to 4 plus 2 raised to 2 plus 2 raised to 1, the value what I get there is a 22 there. Now, for the value 22, if I am shifting right by 3 bits, then, so these particular 3 bits are taken right, and they will be taken out from the bit, and here the remaining places when I get here, this will be appended with the 0. This is the right shift operation what we perform. When you are performing the right shift operation, the 22 when it is right shifted by 3, this is same as multiplying the value 22 by 2 raised to 3. So, the dividing by 2 raised to 3, because when the bits are going from higher position to the lower position, this is same as right shifting is same as dividing the number by 2 raised to the number of bits I am shifting right. So, here 22 divided by 2 raised to 3 is 22 divided by 8, the value what I get here is 2. The integer division what I am taking here, 8 2s are 16, 8 3s are 24 it will be. So, here I have taken only 2. So, the value what I am getting here is 2. This is the way how exactly we perform the right shifting. Fine. Similarly, we have the left shift also. When you are performing the left shift, what happens is 22 when it is shifted left by 3 bits. So, here the bits will be moved left by 3 positions, right? Now, when I am moving left by 3 positions, the last 3 positions will be left vacant there, and these vacant places will be filled with the 0. So, means the lower bit will go to the higher positions here when I am performing the left bit rotation. When I am performing, not the rotation, left bit shift here. So, when I am performing the left shift here, so 22 when it is left shifted by 3, the bits will move to the higher position. So, this is same as multiplying the number by 2 to the power of number of times I have performed the left shift. So, here, so 22 into 2 power 3, that is same as 22 into 2 raised to 3 is 8, which is nothing but 176. If you look at the bit positions here, this is the 7th bit position 2 raised to 7, this is 5th bit position 2 raised to 5, plus this is the 4th bit position 2 raised to 4. 2 raised to 7 is 128, 2 raised to 5 is 32, 2 raised to 4 is 16, the total is 176. So, shifting left by n bits is same as multiplying the number by 2 raised to n. Similarly, shifting right by n bits is nothing but dividing the number by 2 raised to n. This is the concept of right shift and left shift. But what the question asked here is we are supposed to rotate the numbers. Rotating a number means, now consider the 16-bit value 0 0 0 0, 4 bits, 8 bits, this is the value 7 here, right? So, this is a positive number because MSB bit is a 0 here. Now, here 4 bits, 8 bits, 8 plus 4 12, 12 plus 4 16, this is a 16-bit number, fine. So, now if I am rotating this by 1 bit, then see, first we should see that when I rotate this by right shift by 1 bit, the result what I get is 0 0, all zeros, and 0 0 1 1. So, here this bit will be taken out and the last bit, so in here I will append the 0 here. This is the value what I get when I perform the right shift. But when I perform the right rotate here, this is right rotate. When I perform the right rotate here, the consequence what we will get is this one will come to this particular position, means it will be, number will be 1 0 0, then this 0 will shift here, then 4 zeros, then this 0 will be shifting here, then again 4 zeros, and then this 0 will shift here, 00, and here 11, because that 1 has come to this particular position. This is the value what we get. So, when you perform the right rotate, fine. But here the number has become a negative number, because MSB bit when it is 1, this is a negative number. So, is the reason in the question it is asked like this has to be a unsigned numbers only. When it is unsigned number, this will be a larger integer value, positive integer value. If it is a signed number, this becomes the negative value there. So, is the reason the question is asked like we have to perform on the unsigned number. Now, what is the value correspond to this? So, here the value what we have taken here is 7. Now, when I right rotate the 7 by 1 position, the new value what I get here is 2 raised to, this is the 15 position. I am start from the 0th position here, we end up to 15. 2 raised to 15, so plus, so 2 raised to 0 and 1. 2 raised to 1 plus 2 raised to 0. This is the value what we get when we perform the right rotation by 1 bit. Fine. Assume the situation as something like the last bit is 0. When the last bit is 0, let me consider the sequence as 4 zeros. Now, so this value is correspond to 6. When I perform the right rotation here, or first when I perform the right shift, let me consider, then we look for right rotation. When I perform the right shift, all the bits will be shifted right by 1 position, and in the left end we will add 1 additional 0 there. So, what we exactly we get here is 4 zeros. This 1 0 will appear here when I perform the right shift, again 4 zeros, and here also 1 0 will come from the left hand. So, here, so we are shifting right there. So, from here we get 1 0, and here what we get is 0 0 1 1. And this 0 has removed, and here the 0 will be added there. Fine. So, this is the right shifting, but the same number when I perform the right rotate. When I perform the right rotate here, so what exactly happens is this 0 should go to this particular position. Now, here we can see that, so we get the same number, that is after right shift what we get, the same number we get even after right rotate also. Fine. Whereas, if the last bit is 1 here, then the right shift will give different result, right rotate will give different result, right. So, this is because right rotation here when I am performing, if the last bit is 0, then when that is taken out from the right shift, here the remaining position will be assigned with the value 0. When I perform the right rotate here, so the 0 should come to this particular position. So, when I perform the right shift, what symbol I am appending here, the same symbol will appear here when I perform the right rotate also. The same 0 will appear here. So is the reason when the last bit is 1 0 here, right rotate and right shift both are same. And in the binary number, whenever the last bit is 1 0, then the number is an even number. Number is an even number. But whenever the last bit is 1, the number will be an odd number. In case of odd number, the situation will be like when I perform the right shift, only 1 bit position it is shifted right, and this one will will be removed, and in the left side we will add 1 0 there. So, here the value we get it as, so all here. So, finally after shifting right by 1 bit, it is same as, so dividing the number by 2 raised to 1. So, when I divide 7 by 2, we get 3 value. So, this is the value correspond to that. But when I perform the right rotate, this 1 should come to the higher position here, the MSP position. So, here after right rotate, what I am getting here is, so this is the sequence what I get. So, what's the value correspond to this? 2 raised to 15 plus 2 raised to 1 plus 2 raised to 0. This is the value what I get here. So, what is the exact value of 2 raised to 15 here? So, this is something but 1024, 2 raised to 10 into 2 raised to 5 is 32. So, what's the value here? So, here the value correspond to this is 8 32,768 plus 2 raised to 1 is 2 plus 2 raised to 0 is 1. So, this is same as 32,771. This is the value what I get here. So, when I perform the right rotate, but when I perform the right shift here, I get the value as a 3. After performing the right shift, I get the value 3, whereas after performing the right rotate, I will be getting the value as 32,771. So, based on this particular knowledge, we have to program this. Fine. So, let us see the program, how exactly we do. So, perform the right rotation of the number. Now, so look at this particular code, what we are exactly trying to do here. So, the first we have to define the prototype, first we have to declare the function here or the prototype of the function. So, here the name of the function is right shift, and the value what it is returning is an unsigned number. So, here everything we program using the unsigned number here. It is taking two parameters, both are of type unsigned. So, here x and n. So, x is the number and n is the number of times the value of x should be rotated there. Now, so here I am declaring a local variable x, n and a result. So, clearing the screen using this. So, for this you are supposed to include there conio.h header file. Next is enter an unsigned number. You are reading a number, and here you have to use %u, because when you are using the unsigned numbers, you must use the %u as the format specifier, %d for the signed numbers, decimal numbers, integer values, whereas %u is supposed to use for the unsigned numbers. And you see here, even if you don't write unsigned int there, even if you don't write int, it is treated as an unsigned integer only, right? So, here I am mentioning unsigned int, whereas here, so I am not mentioning unsigned int, rather I just specify unsigned there. So, when I specify unsigned, it is nothing but an unsigned int only. Now, so I am reading the unsigned value, integer value x, and enter the number of write rotations to be done. So, I am asking for the number of times the bit to be rotated. So, I am taking that value as n. Now, result is equal to right shift of x comma n. So, this is the function which perform the rotation of the x by n bits. So, it performs the operation and it gives the result. And here on right rotating, so %u by %u bits, we get %u x comma n comma result. We are displaying the result, and you can see that this right shift what is there. So, this is not presenting here how exactly it is performing the right rotation. That is what the functions are. We just call them, and we do not know that how exactly they do it, but we just knowing that what exactly they do, right? So, right shift will perform rotation of x by n bits. That is what the function says. But here, so how exactly it is implemented, we will not be knowing that. So, that is what. So, the what exactly is done is hidden from the top, how exactly it is being done there. That is what the concept of function says here. Now, so here prototype is given and the function call is also made here. Now, only thing left is the function has to be defined. So, here we can see that the function is closed, the main function is closed here. After closing of the main function, we define the definition of the right shift. Now, so look at the code of the right shift function here. Again, the unsigned is the return type of the function. See, return type, the parameters it is taking, and the name of the function, everything should match with respect to the function call we make, and even the function prototype we have declared, right? Now, so the return type is unsigned int, and right shift is the name of the function, and it is taking two parameter unsigned x comma unsigned n. Here I can take any names, but to make the programming more readable, I am taking the same variables here, unsigned x and unsigned n. Now, so here I have taken one local variable unsigned int I. Within a block I can declare this local variable. You will get to know what exactly the local variable maybe at the end of this session. Now, unsigned int I. Now, for I is equal to 1, I less than or equal to n, I plus plus. These many times I am supposed to rotate this particular number x. Now, I check here x mod division 2 is it equal to 0 or not. This reason is because to confirm whether the last bit is 1 or 0. We have seen that in the example in the what we have performed here. So, for the even numbers, MS last significant bit, this is LSB, least significant bit, this value will be 0, and when the LSB is 0, rotating right is same as shifting right. But when LSB is 1 here, rotating is different from that of the shifting. Right. So, now, so how to tackle this particular problem here? So, if the number is an even number, then obviously the least significant bit will be 0. So, the rotating right is same as shifting right. So, here shifting right. So, here when in the program, when the number is even, how to check that? X modulo division 2 is equal to 0, then what we do is x is equal to x right shift by 1 position, right? This is same as right rotate. The result will be same only. Else means what? So, else means if the number is an odd number, then the least significant bit will be 1. In that particular case, what is to be done? So, in this particular case, carefully understand the logic of this coding here. The situation when the last bit is 1. So, that is when least significant bit is 1, how exactly we perform the operation here. Now, we see that when the value is 7 here, when it is right shifted by 1 bit, the value what we get here is 4 zeros, again 4 zeros, again 4 zeros, and then so 0011. This is the value correspond to 3. So, that is when I shift 7 by 1 bit, this is same as 7 divided by 2 raised to 1, this is nothing but a 3. So 2 3 is a 6, I get the integer division I take, this is same as the right shift. Now I supposed to perform the right rotate. Right rotate means what? So this 1 should appear in the leftmost part, right? So here what I perform is, when I perform the right rotation here, this 1 should come to the beginning. So here for this value I am going to add this particular value. Now what I get here is, when I perform here the addition, fine, I will be getting this particular sequence. Is this the one which we expected? So when you are performing the right rotation here, so fine, this one will appear here. This is what we need. But how to get this particular value? Sorry, here it is 0 0, so it is not 1 1. So this is the value which is added to after performing the right shift. What we get, this is the right shift, and to get the result for right rotate, we'll add this value and then we get the new result. This is after right rotate. This is after what we get is right shift. This is right shift, whereas this is a right rotate. So is the reason we are adding this value. How to get this particular number? Now take an integer value 1, and the binary sequence correspond to 1 is this is the binary sequence correspond to 1. Now if I go on shifting this left by 1 position 15 times, if I perform the operation, then what will happen here is, so this is shifted to this particular position. One bit rotation means it will come here, left bit. Now second time when I do, it will come to this position when I perform the left shift operation. Third time it will come here, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th. 15 times when I perform the left rotation, what I will be getting is the value here. 15 times when I perform the left shift, I will be getting the 1 here. So what I do now is, this value I am going to add here to get the result for the right rotation here. This is what we do in the programming. You see now, when the number is an even number, x modulo 2 is equal to 0, x is right shifted by 1 bit. Similarly, else means the number is an odd number. Then what we do is, x is equal to x right shift by 1. So when I perform right shift by 1 operation. Now when I perform the right shift here, the last significant bit, the least significant bit 1, what is there, that has to be added to, that is to be brought to the first position. So that is to MSP position. What we do now is, x is equal to x plus the value 1 when it is left shifted by size of int into 8 minus 1. If I am using 16-bit machine, size of int will return 2 bytes. So 2 into 8 is 16, 16 minus 1 is 15 times I am performing the left shift, and then I am adding to x to get the result of a right rotation. And if I am, in case if I am using a 32-bit machine, size of int will be 4 bytes there, 8 4s the 32, 32 minus 1 is 31 times I will be performing the left shift, and then I am performing the addition. This is most important here, fine. So based on this particular thing only, that we are performing the right rotation, fine. So this is normal right shift. Right shift is same as right rotation when the number is an even number, but when the number is an odd number, the LSP, the least significant bit, has to be brought to the first position, that is MSP position. So what I do now is, I will perform the right rotation, right shift first, and then for the resultant, so for x I will be adding here, so 1 left shifted by 15 times or 31 times based on the size of the integer here. Size of int will return 2 bytes. It just, if I do not multiply with the 8, then it is like 2 minus 1 time I will be performing the left shift, because the size of int will return, this particular operator will return the number of bytes, it is not give the number of bits. So it has to be multiplied by 8 there, and after performing all the shifting, so rotations n number of times, finally I will be returning the value x here. This is the program, so which will perform taking an x unsigned value and taking an n unsigned value and rotating the value x by so n number of bits towards the right. Now, so this is the sample output what we get here. Enter an unsigned number 16 and enter the number of right rotation to be done 2. So when I perform right rotation by 2, the value what we get is 4, because when we look at the value 16 here, the sequence what we get here is when you take the value 16, the sequence what we get here is 0, 1, 2, 3, 4. This is the 4th bit position. This value 2 raised to 4 is equal to 16. So this is the value what we get there. Fine. Now, when I perform this right rotation by 2 bits, now this is same as right shifting by 2 bits. These two zeros will come here and then we get the result. And when I perform the right shift here, so what I get is 2 bits means these two zeros will be taken out and that will be added in the other end. So this value, this binary sequence is correspond to 0, 1, 2. 2 raised to 2 is 4. The value what we get there is 4. So is the result. So on right rotating 16 by 2 bits, we get the value as 4. Similarly, enter an unsigned number. I am taking an odd number. When I am taking the odd number, enter the number of right rotation to be done. It is 1. So when I perform the one shift right rotating by 1, then what will the value I will be getting there is 32,770. How exactly I am getting 32,770 there? So here when it is the value 5, then the sequence will be like 0, 1, 0, 1. So this is the value corresponding to 5. Now when I perform the right rotation, so right rotation by 1 bit, then what will the sequence I get? This 1 will come to this particular position. So that is the sequence what I get will be like, so this will be moved, 1 0 will be moved there, 1 0. This is the sequence what I get after performing right rotation by 1 bit. Fine. When I perform the right rotation by 1 bit, this one has come there. What's the value correspond to this? It is 32,000. This is nothing but 2 raised to 15, so which is 32,768. Now for the value 32,768, and this value should be added. So this is 0, 1. This is plus 2 raised to 1. So that is nothing but 32,768 plus 2, so which is 32,770. This is the value what we are supposed to get there. So is the reason here we can see that on the when I right rotate the value 5 by 1 position, we will be getting the value as 32,770. Similarly, if I take an unsigned integer 7 there, when I perform the right rotation by 3 bits, I will be getting the value as 49,153. This is the way how exactly this program works. Now we look into the another program, the next program number 10b. So here design and develop a C function. So is prime. So is prime is the name of the function. It is taking a number as a parameter that accepts an integer argument. It is taking an argument of the parameter num, so which is of type integer, and returns 1 if the argument is a prime. So here if the number is a prime number, then it will return 1, otherwise it will return 0. Now using this function, what is to be done here? Write a C program that invokes this function to generate the prime numbers between the given range. So between the given range, so what all the prime numbers exist, that has to be printed making use of this particular function. So first of all, here we should understand what exactly the prime number is. Basically the numbers which is divisible by itself and 1 only are called as the prime numbers. No other multiples of, so factors of a number we find other than 1 and itself. So such numbers we call it as the prime numbers. So here, say for example, so the 1 is neither prime nor a composite value, right? The prime number starts from the value 2. Now after this we get the value as a 3, 5, 7 and 11. 9 is not a prime number. It is divisible by 3. The numbers which is divisible by 1 and itself only are the prime numbers. 2, 3, 5, 7, 11, 13. So these are the numbers so which are divisible by only 1 and itself. So these are all the prime numbers. Now how to check for whether a number is a prime number or not? Say for example, if I take the number as something like 167, so is it a prime number or not? So how to check here? So what the logic what we can apply here? We start from, so the number should be divisible by only 1 and 167. Apart from this, no other number should divide this 167. So what logic we can apply here is like, so we can take a loop for I is equal to 2, or I can say here I less than or equal to 166 I plus plus. Fine. So here I can check like if 167 modulo division by I equal to 0, print of not prime. Fine. When I come out of this loop, I can print prime. I am just writing here P of just for our understanding. That's it. Now, what exactly the logic this says here? When I is equal to 2, I will check whether 2 divides this 167 or not. If I get the remainder 0, I can declare that it is not a prime. We have some other number which can divide 167 apart from 1 and 167. So, I will try with the 2, 2 will not divide. I will try with the 3, 3 will not divide. I will try with 4, 4 will not divide, and I go with 5, 6, 7, 8 up to 166 only, right. Start from 2, go only up to 166. If none of these numbers divide, then we can say like I will be coming out of the loop and I say that the number is a prime number, right. And whenever I declare here the number is a prime number, I can exit from the program because I no need to perform. So, further, so if any one number is dividing it, that is sufficient to say that the number is not a prime, right. If none of the numbers are dividing it other than 1 and the number itself, then I have to declare that number is a prime number. This is one logic, fine. So, if the given value is n, then 2 to n minus 1, 1 by 1 I check every number whether it will divide the n or not. This is one logic. The another logic is not necessary that I should go up to n minus 1. So, another logic is 2 to n by 2 is sufficient to check whether a number is a prime or not. Say for example, 167, when I divide by 2, the value what I get is 2 8s are 16, 2 3s are 6. Now, 83 into 2, so what I get is 164. And if I take 84 into 2, the value what I get is 168, right. So, here I no need to check with so here I is equal to 2 I will check, I is equal to 3 I will check, I is equal to 4 I will check, I need to check only up to 83, when I is equal to 83 whether it will divide or not. When I no need to go for the case where I is 84, 85, 86, the reason is 84 2 is a 168, it is no way possible that, so it will divide the 167. We can go only up to n by 2, not mandate that I should go up to n minus 1. This is the better logic compared to this. And still one more logic is there which we can do, like only 2 to square root of n. If I go only up to 2 to square root of n, that is sufficient to say whether the number is a prime number or not. 2 to square root of n means what? 2 to, with respect to the 167, square root of 167. So, what is the square root of 167 here? So, the square root of 167 is what is square root of 13? 196 is square root of 13. What about to 12? The 12 square is, so we get here 144, right. So, the number is 167. So, that is greater than 144, so lesser than 196. So, here 2 to 13 if you verify, that is sufficient. No other number, it may divide, it may not divide. If no number is dividing between 2 to 13, then I can declare that number 167 is a prime number. So, now 2 to 2 will not divide, 3 will not divide, 4 will not divide, 5 will not divide, no need of going up to 166 or up to 167 by 2, that is up to 83. Now, 2 to 13, these divisions are sufficient to say that whether a number is a prime number or not. This is the best logic compared to the 3 logic that we have seen. One is 2 to n minus 1, the other logic is 2 to n by 2, and the one more logic is 2 to root n. Out of these 3, any of the one logic we can use. So, but and I am using the root of n here, I should make use of the math.h, and I should make use of the function sqrt function which is available in the math library here. Fine. So, we will see now how exactly to compute the list of prime numbers between the given the range. Now, if you look at the program here, the name of the function as it is given in the question, it has to be is prime. It is taking an unsigned integer value. Of course, here we can take the signed number also, but here we have taken unsigned number here. Return type of the function has to be int. If the number is a prime number, it says that, so it returns 1, otherwise it will return 0. That is what the question is asked, right. So, in the question, is prime is a number that accepts an integer argument and returns 1 if the argument is a prime, 0 otherwise. So, now if you call the function is prime, so this is the prototype of the function taking an unsigned integer as an argument, return type is integer there. Now, in the main function we take, so unsigned int m, n, result and I, these are the variables what we are declared here. Now, enter a range of unsigned numbers. So here what we do is, so percentage u comma percentage u ampersand m comma ampersand n. So we are taking the range of the range of the numbers within which we are supposed to find out the prime numbers. Then we have to display all the prime numbers that exist between that range. Prime numbers between percentage u to percentage u are, so m comma n, that the prime numbers will be listed by this particular looping construct. So here what this particular printf will display here, like if I give the range as 1 to 100, then it will display like prime numbers between 1 to 100 are, is the display what we get from the first printf, second printf statement here. Now in the loop what I am going to do is, I is equal to m, I less than or equal to n, I plus plus. If m value is 1 and n value is 100, then I is equal to 1, I less than or equal to 100, I plus plus. Each number I will take, I will confirm whether it is a prime or not. Result is equal to is prime of I. When I value is m, I will check with m, then m plus 1, then m plus 2, then m plus 3, up to the value reaches n value there. If 1 to 100 is the given range, then I can check with when I is equal to 1, is prime 1, then I plus plus, is prime 2, then when I becomes 3, is prime 3, that will go up to n, so that I can get the prime numbers between m and n. Now, so here the is prime is a function which will confirm me whether a number is a prime number or not. So result is equal to is prime of I. This function is prime will return 1 if the number is a prime number, otherwise it will return 0. Now I will check the result. If result is equal to 1, print of percentage u, because the value I is a prime number, otherwise I should not display there. So after that, so this all the prime numbers that are within the range will be displayed there. I will be coming out of the loop after displaying all the prime numbers, and then I am going to return here, return 0 there. Now here the main function has been closed here. Now after this we have to define the is prime function. Here this is the function call of is prime, this is the function prototype of is prime. If you look at the function definition of is prime, it is taking an unsigned number as a parameter. It could be unsigned int or just an unsigned, so anything you can write there. And then return type of the function is int. How exactly I am trying to perform the computation of whether the number is a prime or not. Unsigned int I have taken one more local variable, unsigned int I. Now if n is equal to 1, return 0, because 1 is neither prime nor composite. So here 1 is not a prime number starts from 2. So if n is equal to 1, then I return value 0, indicating that 1 is not a prime number. Now otherwise for I is equal to 2, I less than or equal to n by 2, I plus plus. The same logic what we have applied here. 2 to n minus 1 is one logic, 2 to n by 2 is another logic, and one more logic is 2 to square root of n. Here I am sticking on to 2 to n by 2. This is more easier compared to, so this and this is more tedious to the system. Fine, the computer, so it has to perform some redundant checks to confirm whether number is prime or not. So here after 83, no need of dividing the value 167 by 84, 85, 86, 87 up to 166, not necessary there. But still with this logic we will be allowing the computer to machine to perform the various redundant operations. So some donkey work will be given to a system to perform that. Fine, it is not necessary. So we can improve the logic to 2 to n by 2. If I am using 2 to square root of n, then I must make use of a sqrt function, and I should include their math.h header function also, header file also. Anyhow, so here we are using this 2 to n by 2. So here when I is equal to 2, I less than or equal to n by 2, I plus plus. What exactly I am trying to do here? If n mod I is equal to 0, if any number is dividing the value n completely, that is getting the remainder as 0, then that will confirm that number is not a prime, so I return 0 there. If none of the numbers are dividing the value n, then I will be coming out of the loop. After coming out of the loop, I will be returning 1, saying that the number is a prime number. So this is the definition of the is prime function. So this is the program which will compute so all the prime numbers that are present in a given range. Now see the output of this particular code, what exactly we get. Enter a range of unsigned numbers, 1 and 15 I have given. So all the prime numbers that are between 1 and 15 must be listed there. Prime numbers between 1 to 15 are 2, 3, 5, 7, 11 and 13. So we get all the prime numbers that are between 1 and 15. Similarly, enter a range of unsigned numbers, 20 and 65. If I give the range, it is printing the numbers as prime numbers between 20 to 65 are 23, 29, 31, 37, 41, 43, 47, 53, 59 and 61. Fine. So these are the prime numbers that exist between within the given range. Fine. This is the way how exactly this particular program works. Now, so next we will see the storage classes, which is most important, another concept of C when you are using the concept of functions. So storage classes specifies two things: the storage duration and the scope. So what exactly the storage duration is? So how long a variable will be having a life in the course of execution of a program is what storage duration is. How long an object or a program element can exist in memory, how long a memory can be a variable can be existing in the memory. So there is a storage duration, sometimes we call the lifetime of a variable here. The another thing is the scope. The scope means which all the where exactly this particular memory contents of the variables can be accessed, where object or a program element can be referenced in program, in which of the program code segment I can access these particular variables, that will specify the scope. Scope is specifying, so in which particular memory segment of the code, the code segment of the program we can access the variable, whereas the storage duration means it is a lifetime of a variable, how long the program variable will has a lifetime within the course of execution of the program. So you will get to know in the certain examples what we take. Now C supports basically 4 types of storage classes. One is automatic or local, or the register variable, or the static variable, or external or a global variables. These are the 4 types of the storage classes what basically the C supports. Fine. So with respect to the automatic or local variables, so we can use the keyword auto to declare that a variable is local. So fine. So here in this particular case I can make use of the term the keyword auto there. But so whenever within a block, when I am declaring a variable without this particular term the keyword auto also, by default the variables will be treated as an automatic variable or a local variable. The default scope of variables declared or defined within a block is a local or a automatic. The both mean the same, local variable as well as the automatic variable. Then these program elements are created and destroyed within its block, means so the lifetime of the local variables will be present only within the block in which they are declared. In the example you will get to know that what exactly it mean, lifetime of a variable mean. Now no default value exists for a local variable, that is it possesses a junk value when uninitialized. We have seen that even in case of arrays and even in a normal declaration, if you are not initializing any value, the default value what they possess is the some junk value, or uninitialized means they possess the junk value or some garbage data there. These are the local variables. With respect to the local variables only we have seen so various programs. Now so consider this particular example here. So here within a block, so here this is the main block, this is the if block. So here within the beginning of the block we can declare any variables there. Here I am declaring x, y, z and t are the variables of type integer. Since I am declaring within this main, so these are all the local variables. Within the beginning of the block I am declaring here these are the local variables. I can use here auto int, or I can just use int. The default scope will be of type so local only. Fine. So here x value is 9, y value is 8, z value is 5 and t is not initialized. So the default value what they get is some junk value, means they have some garbage content of the memory, whatever it is there, that will be printed. Now what the printf statement here what it says is x is equal to %d, y, z and t values I am going to print. X value will be 9, y value will be 8, z value will be 5, whereas the t will print the t value will be some junk value, some data will be printed over there. Now if x is equal to 9, as condition is true, I have opened the block here. When I am opening a block here, then again I am declaring a variable called int z and a. So here this is not an error. So this z is in the main block, whereas this z is within the if block. Fine. Now so here I am printing the values of x, y, z again here. So x values, so the 9 value, and y value is, so again here the 8 value, whereas z value will not print the 5, rather it will print the 25, because locally we have declared another variable called z. So this will be having the highest priority than the block which is outside of that, right. So here z will get the value as a 25. So here z will get the value 25, and I have declared one more variable called a, whose value is 55. So a value will get printed there as a 55 there. Now when I come out of this block, now the z will get the original value 5, because so z will die, I mean the life of the z, the locally what I am declared within the if block, z and a will not be having a scope once I comes out of this if block. So here in this printf statement, if I am trying to print a value, then a will not be having any reference. That is what I mean. So the lifetime of a variable, the life of the variable locally declared z and a is within this particular if block only. When I come out of the if block, this z z will not be there, rather I will be referring to the z which I am declared in the main block here. The value of z will be 5 there. So, here x value will be 9 as usual, y value will be 8 and the z value what it prints is 5, not the value 25, because this z is nowhere existing when I am coming out of this particular block. And similarly, a is also I cannot access here, z I can access only because z is declared in this block also. If I use here a is equal to percentage d comma a, if I try to print the a value, I get an error as undefined symbol a in function main. So, that will be the error what I get, because this a has a life within this if block. When I am coming out of this if block, then a will not be having any reference. That is what the meaning of scope and the lifetime. Life of this particular variable is within this block only. Outside this block, I cannot access these particular variables. That is the reason why we call it as these are locally declared. These are automatic variables, fine. So, which have a lifetime within this particular block only. Now, we have another type of variables called register variables. Here we can declare a register variable by making of a keyword called a register. We can declare a register variable as register int flag is equal to 1, something like this. Register is the keyword using which we can declare a register variables. The one speciality of these register variables is these are not stored in the memory, rather they are stored in the high speed registers. Whenever in a case of loops, if I have some 100 types of iterations has to be done in a loop, instead of storing that in a memory, if I am storing that in a register, then that will enhance the execution speed of the program. So, is the reason. So, for faster execution, sometimes we are supposed to declare a register variable. So, register variables are stored in a high speed register. Since they are storing in the registers, they do not possess any kind of addresses. Registers will not be having the address. Only the memory, with the data that is stored in the memory will be having the address, that is in the random access memory, whereas if the data is stored in the register, they will not possess any kind of addresses. And one more feature with respect to register is like register variables can only be used as automatic variables. You will also see one concept called global variables. So, register variables cannot be declared as a global variable, they can be declared as only as the local or automatic variables. Register variables are not stored in memory, so they do not have addresses. Since that is what we did, I have told. So, register variables are stored in the CPU register, they do not possess any address. These values are not stored in the memory. So, since they do not have the addresses, using a pointer I cannot hold the address of a register variable. So, no default value exists for the register variable, similar to the automatic variables where we do not have any kind of default value. They say they have the junk value. Even the register variables also will be having the junk value when uninitialized. Say what exactly the meaning of they do not possess the address is, if I am declare register int x and here star y, then I can declare here int star ptr comma say for example a is equal to 5. Now, if I say here x is equal to ampersand of ptr, sorry, ptr equal to ampersand of x, this is invalid. This is invalid only because, so x is declared as a register int. When it is stored in the register, it will not be having the address. I cannot access the address of a variable. Whereas I can say like y is equal to ampersand of a. So this is valid because here, so y is stored in a CPU register, but the thing is y is holding the address of some other variable. So y is not having address, but y can hold the address of some other variable. So this is valid. Whereas, so this particular statement is invalid, fine. So because here we are trying to hold the address of a register variable. Register variables will not be having the address, so it is so not possible there, fine. So then, so we will see the static variables is another concept. So using the keyword static, we can declare a static variable. Example, static int flag is equal to 1. These are similar to the local variables. The only difference is static variables are similar to local variables, except that they hold or persist their value, fine. Throughout the execution of the program, the lifetime of the static variables exist, and only thing is, so automatic variables will, once we come out of a block, they die, whereas the static variables is not the case. So they persist for the throughout the execution of the program. program. And one more feature of the static variable is, so they initialize only once. Static variables are initialized only once. The static variables exist for entire program execution, and the default value of a static variable is 0. If I declare a variable as a static int, something like that, so then the default value what they get is a 0. Now consider this particular program here. I am declaring static int x is equal to 5. This is the first time I am initializing here. This is the name of the function display. You see here I am defining the function display. So here I don't have a prototype of the function display. The C programming rule is like, before I call a function, that must be either declared or defined. So here I am defining only, so no need of kind of having a declaration of the function display or the prototype of the function, or another way the signature of the function display. So static int x is equal to 5, the value of x is equal to %d comma x, that x will be printed, and later I am incrementing the x value. Now you see here what exactly happens. This is compilation one. Now in the case of execution, the execution start from the main function. Int I, for I is equal to 1, I less than or equal to 5, I plus plus. When I is equal to 1, I call the display for the first time. When I call the display for the first time, it will initialize the x value as 5, and this is a static variable which will be initialized only once. So it will print the value of x as a 5, then the x value is changed to 6. Again it will come out of the display. When it come out of the display, again it will go for incrementation of I, coming back to the main function. I becomes 2 there, again it will call the display. When I go for second call of display here, now this particular statement will not be executed because it is initialized in the previous call only. Fine. So then here what happens is print of value of x equal to %d comma x. X value was a 6, so the 6 will be printed over there. Again x will become, so x plus plus x becomes a 7. If it is a local variable, after coming out of this block, this should die. But here that is not happening. So this x will persist for the entire program execution time. The lifetime of this particular x will be for the entire program execution, and they persist the value what they are holding. They do not lose the content of the memory there. So output of this code when I am executed, so we get the output like value of x is 5 when I is equal to 1. Second time it becomes 6, 7, 8 and 9. After printing the value of 9, the x has become 10 there. The next time if I call display, the value of x could be 10 over there. This is the normal output of the static variables. But the same program, if I am treating it as int x is equal to 5, then every time when I call the display function, it will come here, it will initialize the value of x as x to 5, and it will print the value of x as the value 5, and again x becomes the value 6. Now second time when I call, again I am declaring locally the variable x as 5, so initial value of x as 5, which is of type integer. The value of x will be printed there, again x becomes 6, and when I come out of the void function, so the display function, again x will so die over there. Fine. So that's how exactly how the execution will work. The output of this could be like 5 times when I call, in all the 5 times the value of x will be printed as a 5. Fine. So I will stop here. In the next class we will see the concept of global variables, and the 2 other remaining programs of the lab exercise will complete, and will complete this particular concept of functions, strings and arrays by the next session. So thank you.